Good evening, everybody. I'm going to talk about the multi-agent applications, and I powered this by Semantic Kernel. Who here is already developing AI agents? We've got two persons, so hopefully after this session, you all get inspired to create your AI agents, because an agent is fun, and one agent is cool, but what if you can have more? And what if you can create a whole army of intelligent agents that are working together and are going to take over the world?
Some countries would love this presentation, I think.
Yeah, definitely. So we will dial it a little bit down, and we will just start on example applications, which I will show you in the end. So who am I? I am Paul Stolk. I work at Syria. I'm a software developer, also a Microsoft certified trainer, and I organize events for Booyah. This is a LARP. LARP is just Dungeons and Dragons in real life. So in my spare time, I put on a costume and go around with a bunch of friends, trying to smack them in the head with a foam weapon and have some fun and tell amazing stories together. I'm a storyteller in heart, and this is why I love working with these large language models, because they are very good at creating stories. In the session of Roland, we learned that they are not actually creative. However, they do a very good impression of being creative, so I like that very much. So what are we going to talk about today? First of all, we're going to start with what are AI agents. Most of you might have heard the term, but we will dive into my definition of what an agent is so that we are all on the same page. I will show you how to build one, what the orchestration is, and in the end I will have a live demo of two solutions that I've built with agents, two with totally different purposes, but you can get the gist of it when I get there. So the world before agents. ChatGPT was there once upon a time, and it was glorious, it was good, it helped us create and write essays, it helped us create summaries and all that kind of stuff. And we have the AI assistants, the Google, Siri, all AI driven, but they're not really agentic because they have one single brain. They are one single focused tool. So what are they doing? They have this one single brain, and they are excellent for very focused tasks. So let's say, for example, ChatGPT is brilliant for text editing, is brilliant for creating summaries or coming up with new recipes or whatsoever. But it's all still one AI brain, one model that is working for us. Once we want to do more complex things like multi-step tools or want to browse websites or get all that kind of information, it gets a little bit trickier, and that's where agents come in. And the memory for long-term tasks are, the context window Roland showed us is getting bigger and bigger and bigger, but in the beginning it was rather small, and now it's getting bigger. But still, if we want all those different workers, all those interns, basically, an AI agent is somewhat like an intern. We want them to know and share the knowledge. That's not possible with one single brain, so we need to give them a little bit more. So what are actually the building blocks for an agent? Well, first of all, we start with a large language model. We need to give it very clear instructions. It needs to have memory. It needs tools and prompts and all that kind of stuff. But basically, it is a large language model. It's ChatGPT of some kind. It's just a large language model that we can prompt, and we can get it to do stuff. So these agents are, when we are starting building an agent, we need to think about dividing and conquer. One person cannot be good at everything they do. For me, example, I'm a developer, but I am very bad at creating a beautiful design. I have the graphic skills, well, even my stick figures are not pretty. So someone else needs to do that. With agents, it's not different. You have these agents are specialized when we are using them. Or at least that's the main idea behind them. We are giving them, each and every single one of them, we're giving them a specific job to do. And we want them to work together. Because only when they work together, we can create some real magic. So, in order to work together, they need to share memory and goals. And the chat history of what happened before is also very recommendable to share that between the agents. Because if you don't share the chat history, they don't have access to what I said before and might start to hallucinate and come up with completely different ideas that we didn't ask for. So memory, besides chat history, is also useful. Because when we are putting these agents in a working together mode, for example, they are going in rounds, they are having a group discussion, it's very useful for them to remember what has been said in the past or what someone else said. So we create a memory between them. And we need to make sure that when we are creating an agent, we give them one common goal or a common objective. For example, later on I will show in a demo that I created a production line for an application. The common goal over all of these agents is to create an application in the end. All the specific agents are not aligned to that. If the agents are not aligned to that goal, I will not end up in the end with an application. So sharing the common goal is very important. And if we go and look a little bit further in these specializations, for example, research agents, web research or whatsoever, if you give an agent a tool, you can give them the power to do stuff. Without tools, they're just chat interfaces. They are just large language models that give us a lot of information, but they cannot do something together. In order for them to work together, we actually have to enrich the large language models with tools. So in this example, the specialized research agent, I gave access to the internet, so now it can go to the internet and get information over there. If you have any questions, by the way, please feel free to ask. Same goes for the developer agent. The agent is very specialized in developing applications in a certain language. It doesn't get to pick and choose which language it's going to use. I created an agent and I told them, you are a .NET developer, because I wanted, in the end, a .NET application. If I didn't give that as input, who knows what he might have come up with. But I wanted to be in control with the whole tool, what in the end would be the output. And a project manager, same for that one. It needs to manage the project, so it needs to know what to do. And if you put them all together, you create something that's dreamwork or teamwork. All of them working together, it's creating magic. And I don't know if you've noticed when you are chatting with a bunch of colleagues and you're starting brainstorming and throwing ideas all at the same time, without any hierarchy. Thank you, Al. Thank you. Without any hierarchy, things will break down rather fast. So you need something in charge. You need an orchestrator. And with an orchestrator, you also need to have very clear instructions. Again, the prompting that we do to these agents is very important. If the agent is not behaving the way we want it to, most likely the prompt is not correct. Or it's not accessing the tools that we want it to. I don't know if you've had any experience with that before, but I myself had agents who told me very specifically that they were using the tools that I've given them, but in fact they weren't. They were just hallucinating. So, how do you manage this all? If you're going to start to manage this all, you are sort of diving into orchestration challenges. Because for certain solutions, you need different orchestration types. A brainstorm is fun unless you want them to do stuff in a certain order. Also, error handling. when an agent throws an error, the whole application can stall and be idle and running and not showing anything. Or directing tasks to a certain agent is also something that you might run into. Luckily, Microsoft has given us a framework, and this framework they've given us is Semantic Kernel. Yesterday, they announced a new framework. They have announced the Microsoft Agent Framework, which is sort of the same, but a new updated version. And I'm gonna stick to Semantic Kernel for now, because the demos are in Semantic Kernel. But the new framework that is provided by Microsoft is built on the framework of Semantic Kernel. If you replace the usings on top of the C# pages, it will most likely already work. It might be that some namespaces need to be adapted. Yes?
Expert opinion. Why did they do this? Any idea?
I have no clue why they changed the name of the framework. I think that they wanted to have the focus more on agentic.
Rebranding, or is it a completely?
They changed the name and they added some more goodness to it. So they extended actually on it, and they you have this other framework of Microsoft that is. Thank you, AutoGen. I was gonna speak on my phone, but thank you. AutoGen is also there to help create agents, and they basically combine those two and build upon that. But I've read only like 10-15 minutes of information on the whole page, so keep that in mind. Also, a lot of things that are happening right now are still in public preview. Certain things are out there for a longer time, certain things are just in preview, like features of Azure AI Foundry. A lot of the features are still in public preview. So this is cutting edge. Basically, Microsoft might come up with a new brilliant idea and change the whole design overnight, and then we have to adapt on that. So, but Microsoft has provided us with a framework, and this framework is an SDK, and it helps us. And it is with .NET 9, the support of the Microsoft became way better than it was before, because before there was already Semantic Kernel. Now it's really good, and it also supports agentic and the tool calling that we like to do, and we can create custom tools for our agents and so on and so on. So it's deeply integrated in .NET, and it's a specific SDK basically for working with AI. And it's created for us, what Microsoft does is they created abstraction layers for us. If I want to work with local models like with Olama or Foundry Local, or I want to have the goodness of Microsoft Azure AI Foundry, I can do it all with one abstraction layer. And all those new plugins and the thing that they announced as well with the Microsoft Agentic Framework is in Microsoft Extensions.ai. So it's already there. When we want to use it, they basically extended the library. So I already said something about tools and agents. So if we want to build an agent that can access our file system, or can access the internet, or can access our API, all those kind of things, we as developers need to provide for the LLM, because the LLM doesn't have access to it. We can do this by the Model Context Protocol, or MCP. I don't know, has anybody here built an MCP server? Quite a few already done this. What it is, MCP is a protocol that is a standardization for us to talk to web service or APIs and other applications. So with an MCP connection, I can actually access my own file system. I can write data to my file system, but only to a limited folder, or it all depends on what limitations I set, but it's very smart to set certain limitations to your folders because we don't want to have it access to our whole file system. Yes?
Does the MCP support in Semantic Kernel also support
Yes, I have tested this. I have a web API which I need to enrich the calls with a certain header, and I can do this. I can do this both for an Open API call, because there's also an Open API plugin for the agents available already. But you need to be able to enrich those things, and it can all be done within Semantic Kernel. So Microsoft has given us really the tools to do this. And also they helped us with the orchestration types. So how does one initialize the Semantic Kernel to actually start all these amazing tools? I created a function, and you can see on screen. Basically what it does, we have a kernel that creates a builder, and then at this builder we can add all the kind of connections. So in this particular case I add an Azure OpenAI connection, but I just as easily could have added an OpenAPI connector to it as well. I give it a couple of parameters, like an endpoint, an API key, and which model I want to run, and I return a builder. And after I've done this, I can actually initialize my agent. So I create the Semantic Kernel version, and then I can create my chat completion agent, which needs a kernel. It needs a name to know, okay, I can call this by its name. It needs a description. This description helps other agents as well when to call a certain tool, as does the name. So it all helps, and it needs a set of instructions. You might notice that this specific agent does not have any functions at this moment available. We can add those functions to the Semantic Kernel initialization and make them available to all who create a new kernel, or we can add it later on to our specific agents, and I will show you in a live demo how you can actually do this. And there are some, you can even say it's required that you call this tool, or this tool is, up to you when to use it, or don't call this tool at all. Usually it's recommended to let the AI agent determine when it starts to call tools. So how do you go from one single agent to a whole team? Because once these agents are actually starting to work together, that's where we create magic. Orchestration is the key. I already said it before. It's very important to tell the agents on how to work together. They might want to work as a group, or keep the human in the loop, or we want them to run autonomously. All these options are available for you in Semantic Kernel. Microsoft has built in full support for this, for as full support goes for an in-public preview feature. So you can actually influence on how they want to work together. For example, when you go to a concurrent stage, they are all working at the same time together. And we get something to like an architecture picture of this. We have a bunch of input, and then we have a bunch of agents working on this together, and we have a collector. That collector aggregates the results and gives the results back. And then for you as a human, you can decide what you want to do with these results. It's recommended for these kind of tools that you let them run for quite some time, because the agent decides when it's done. When it's working on something or generating something, or it's thinking or whatsoever, it's going to take its time. And if you say you are only allowed to work on this for like 60 seconds, you might run into the issue that it's not done yet. You would throw an error and so on. Same goes for sequential. One block built on the other. So the user has a bunch of input, let's say a summarizer, then they pass it through an translator, and in the end we have a translation that needs to be reviewed. Is this actually working with what we had as input? And then the user gets a result. But it's all depending on what kind of agents you put into the chain. You can make these chains as long as you want. If you want to have 5 agents in a sequential turn, you can. but the orchestration runs for an X amount of time or unlimited. It all depends on what you set as a user. We also have this group chat, which is actually a round robin. It goes on and on for a maximum number of times. You are in charge on how many times they can actually do this circle or how many times a certain agent gets called. So as we look at this, there might actually be one of the agents might request a little bit of feedback, but we get that in the human in the loop more clear. But we have a group chat manager, and that one is actually talking to each and every one, getting their responses, collecting them, and giving us a result in the end. So then we have the human in the loop. The human in the loop system, you might have guessed it, there's a human, and all the agents can actually access the human. So if we have this orchestrator who decides, okay, now this is task for agent A or agent B or agent C, and agent C thinks, okay, I need to have input from the human. The agent C can actually contact the human, depending on how you build the system, but it should be able to call back to the human. The human gives input, agent C continues to be working. And at the end, when they are all complete, you have the end result. And then we have the full autonomous system, which is basically a fire and forget job. A fire and forget job looks something like this. I have a bunch of tasks that I need to be doing, and all these agents go on off and do their job. Is my task complete? Yes. Okay. I can mark myself as complete, and the orchestrator will no longer keep watch on that specific agent. And so on until all the agents are done. And when they are all done, then finally the agent will say, or the orchestrator will say, okay, look, I'm done. So the tooling that we can add to our agents, again, I've said this already before, but it's very important that the agents on its own is just a large language model, and we need to give it access to tooling. If you don't give it access, it doesn't have any goodness. So let's dive a little bit into a demo. I will first show you an application that is basically a production line, a developer production line. As input, I can give a task. I want to build an application, and it will go and do its job. On this particular job, I didn't implement any orchestration or whatsoever. I created a second application that actually integrates the orchestration a little bit better, but I will show you that in a bit. So if things go right, you see what I see. Live demos are always an option. Is it readable? Let's make it a little bit bigger. I created this application and this is all prototyping, so there might be some bugs that might not be the most beautiful code you've ever seen. But what I clearly want to demonstrate here is that I have these different phases. So in the first phase of this application builder, it starts requiring all the requirements. And if we dive into this a little bit further, we actually have 3 different agents at this point. I've got a product owner, I got a UX designer, and I got an architect. And they will start working on the job and try to create a requirements document. And afterwards, they will validate that these requirements actually are complete and can be handed off to the second phase. So I've got a bunch of requirements, and I will run the program in a bit, but I really want to focus on this specific part. I got a product owner that's actually trying to approve the requirements that have been created. After the product owner gives his approval, then the UX designer starts trying to give its approval. And if it's not giving approval right away, it will apply changes. So when we go to the UX designer method, I will have, I look into the result of the agent for the word approved, because I said that in my prompt, respond with approved if the UX design is actually considered to be complete, or needs UX revision when it actually needs revision work. If the result is not complete, it will automatically try again, take the input as the requirements, and try again, and give itself feedback on what it needs to approve. So it actually starts to improve itself to create something. And it will try 3 times, and if it then doesn't work, it will get back to me with, hey, sorry, I cannot do this. Maybe I need some additional input. This same goes for the architect, and the same goes for the product owner in the end as well. So when I try to run this, it will now start the working process, and the product owner has now created a suggestion for this. And it asks me actually, do I like this, or do I want to make more changes? Well, in this particular case, I don't want it. And it actually starts working with the UX designer, and the UX designer is going to analyze, okay, do I have enough information, yes or no, in order to create this project? And it starts to work on this, and will be running for a little bit.
It's nice to see that your AI still thinks it's Azure AD.
Sorry?
In the result, it said it is still Azure AD.
Yeah. That okay.
A little bit higher, but
Yeah. The agent is really putting out, a lot of specifications for me at this moment. So, and .NET Core 8 application. So, it's still not up to date, and I haven't enriched this system with any tools except for the file system tool. And well, it's still working. So, let me get back to this. Once phase 1 is completed, it will go on to phase 2, which is trying to create the correct prompts for the other systems that are needed. So it will start to figure out, can I create these prompts that the other agents are going to need? And if the prompt indeed is correctly and refined enough, then it will pass and will continue to the next phase, and so on and so on. So then it will create a project structure and development, and then I have a testing phase, because the AI created some software which needs to be tested, and then phase 6, finally it tries to deploy something with Docker, which, spoiler alert, I don't have Docker installed on my machine, so it will automatically fail.
Maybe a dumb question. How does it know when the prompts are correct, qualitatively correct for the other agent?
Well, we had a session earlier today about how to validate a result, actually. Basically, I have an AI agent validating the prompt. Okay, as a developer agent, can I work with the given prompt?
So you have a developer validator?
Yes.
Okay, now I understand.
I created validators with the large language models. So I've got a bunch of large language models here working together to actually, in the end, create something. And they are all working together on trying to, in the end result, create something. And apparently I got this hooked up to something. I think it's currently, given the result, I think it's actually hooked up to the open source model of ChatGPT because of the blocks it is surrounding itself with. And hopefully, when the it's now at the tester phase, so it should have created some files, which, fingers crossed, because my MCP server has been buggy lately. And in the past it actually created stuff, but bin debug generated projects, and .NET Pulse Pong Hub is indeed been created with a bunch of files actually in this configuration and designed it. So by using the access of the MCP server for the file system, it actually was able to write down all these files and create them and all that kind of stuff. So this is just one example of how agents can work together to help us. And this is not the end. We can, if you create a travel agency, for example, someone wants to go on a holiday to a certain place. You need to gather data. You need to gather their information. Okay, when do you want to go? What kind of availability do you have? And if these agents have access to Google Calendar, they can actually look up in your calendar when you are available. So they can start making plans. There is this MCP server for the Google Flight data. So we can look up data from the Google Flights. There are Airbnb MCP servers, so you can actually suggest a bunch of Airbnb locations. And at the end of the day, you can give a whole travel plan for a holiday to an end user. But these agents are all sequential. They are all just one after the other, and yes, they are validating each other, but they are still sequential working at this moment. I got this other demo, which I created, which I called Storyteller. And like I said in the beginning, I love stories. I am very good, or I really like to play Dungeons and Dragons. I really like to play LARP. So collaborative storytelling is something that I really like. And I wanted to see if the agent could actually play some kind of form of D&D. Can you actually get them to play something like that? So, and I will enable the debugging. So let's say that I want to have them brainstorm about the input. A figure stands on a hill overlooking a city and create a story about this. And now it's actually contacting the Azure AI Foundry. And I've got 3 agents working at this moment. One fantasy expert who is really good at fantasy stories and fantasy elements. I've got a sci-fi expert because I really like a little bit of sci-fi mix in there as well, because it gets weird and I like that. And I got a little bit of horror expert because, I like to scare my players a little bit. So what it actually does, it generates a bunch of output, and I'm gonna scroll to the top, because in the light blue you actually, in the in the red is the text that the agents put out themselves, and then I got the final result below, which is actually outputted by the orchestrator who combined them all to one single story, which is a lot of information that's probably not readable when I scroll through it. But the more interesting part on this is when I scroll down a little bit, or a lot, and you can actually see the following, and I don't know if that works on... Yes! You have this... Sorry?
Achievement unlocked.
Yes! You have this fantasy expert, and the fantasy expert puts out a lot of information. And if I go look for it, I should be able to see the sci-fi expert as well. in the output I display on the screen, I see the tokens that I've used, and the input and the output tokens as well. So I can actually keep a little bit of track on the amount of data I'm actually using at this point. And then in the end, the horror assistant did not even get called because the orchestrator did not think it necessary in this particular case to contact the horror agent. So the orchestrator made the call, do I need to contact the horror expert? And based on the input, based on the prompt I've given to the horror expert, it found it was not needed to actually contact the horror expert. So this is one job. They are working together. But I also have this group chat, and let's pray that it works. And when running this demo, the group chat, I've created 3 characters: a hero, a thief, and a mage. And those 3 go on an adventure together. Those 3 have the giant stone shield. You stand before a giant sealed stone door. A strange purple light, and then something more happens. And actually it gave me a final result. And this is the result of those 3 agents working together. So each of them give me something and will then be collected by the overall orchestration. And how does this exactly work? In this particular case, I've got this response callback. So I've got here my group chat orchestration. This is the orchestration that actually orchestrates the group chat. And every time that there is a response, it will call my response callback. So when I hit a breakpoint here, and I will actually run this again. Yes. Here I get my response, and my response object actually I can see which agent is being called at this moment because that's the author, and I can see the content. And there's also a bunch of metadata available for us as well, like when it's created, what's the fingerprint, why is it done, generating text, and so on and so on.
You also see things like when one orchestrator decided not to call the horror agent. Why? The reasoning law?
I have not been able to.
Because that would make it really interesting.
I know. That's something I'm struggling with myself as well. And I will show you in a bit where it gets really tricky and difficult because I actually broke my demo. So I'm gonna show you that. And it used to work, I swear. But I tested it this morning and it decided to not work for some reason anymore. So probably it's still generating, waiting. How am I for time? 5 minutes left. Okay. When I go to the human in the loop, I go to the handoff orchestration, and this one asks me actually for input. And when I go look to the code, it's a little bit different than the other one. And this one has an interactive callback. And this interactive callback actually gives me the possibility for the user to give input and put on the stack as result from the user. So I can actually influence or send data to the agents by the interactive callback. And I will show you why it's not working. This one is actually trying to create a brainstorm about a world. So we have someone who's writing lore for the world, basically facts and history, all that kind of stuff. There's some agent that thinks of monsters that could have lived in this world, and there's an agent that is very good at riddles. So I given this kind of input, and now it will actually try to decide which agent it needs to call, and it decided to call the lore master. But the lore master didn't generate any output. Keeps on asking on input, and no matter what I do, no matter what kind of input I give, somehow it's bugged, and it used to tell me actually stories about the world and all that kind of stuff. So somewhere when creating this demo, I actually botched it. And the last thing I want to show you is the MCP support. Yeah, you can the cost of this can get really fast, really high. However, you can also run this locally with one change in the kernel factory, and that's the very last thing I will show you. But first of all, I created here this execution settings. And these execution settings, I can actually say to my AI agents, what happened?
That's one of the lines.
Okay. Check. What kind of function calling behavior I want in this particular case. And at this moment, I've set it to auto. You have the option of none, you have the option of required, and you can actually, a little bit above this, I actually add plugins from functions to my semantic kernel. So at this moment, I've enriched my semantic kernel with the MCP server, and it actually can write things down to my file system. And the very last thing that I wanted to show you is the switching of models. Because in this particular case, I've got here my Azure OpenAI, and it's hooked to the GPT-5 Mini. But I can also hook this to my local Azure Foundry models, and I can run open source models as well, with only enabling these lines and disabling the others, or Olama support, or switching of models. So that gets interesting really fast. So this was the live demo. So as for agents, currently we are creating them, and we are very in early stages because a lot of features are still in preview, and development goes fast, but it goes faster in Python, as Roland already mentioned in the other talk. But in .NET, we have now availabilities to do this as well. But in the future, I guess that we are getting more and more specialized agents that are running all kind of jobs, and they are going to be autonomous problem solvers. Like I said, the developer example that I said, or the travel agency, those are all up and coming. And it is for us as developers to create something that's very responsible, because responsible AI is a really important thing. So use the tools responsibly. But we are in this moment getting track, and it's going faster and faster and faster. So thank you all very, very much. I would implore you to think in teams, not just in single bots, but actually in teams of people or of interns, of agents that can start working together. It's important that you pick the right orchestration, and Semantic Kernel and now Microsoft agentic framework or agent framework. Please use it, because it's really, really powerful. Thank you all.